move to example 2. So we have the discrete or trivial, like we call it trivial, like it's like a simple, elementary metric. Row. So we are given X to be non-empty set, and we define the discrete metric this way. This is always the definition. Remember, small x is from X, then Y is from X. So we have the Cartesian product of X, it goes to real. So we have this output, right? This is the range. So 0 and 1 are in real. So this is what it actually means, right? So when you have something like this, a function X going to R means for all, let's say A in X, then when your F works on A, then this will be in R. That's what it means. Like this will be the range, right? And this is the domain. All right. So back to metric, because sometimes terminologies are actually important. So let's prove this. Remember, we need to prove 4 things. So the first one will be what? 0 less or equal to rho. Okay, let me just use rho xy less than infinity. Okay, so when you observe these, right, when you observe these given this output, you can see that the two values for rho of xy is actually 0, 1. So that shows 0 is less or equal to rho xy, which is less or equal to 1. So these are the values for rho xy. So it's between 0 and 1. You can see 0 and 1. And definitely 1 is less than infinity. So that shows 0 is less or equal to rho xy less than infinity. So this is satisfied. Then we need to check the second one. When is actually rho xy equals 0? Remember, rho xy equals 0 if and only if x equals y. Remember, whenever you see if and only if in mathematics, you have to prove in 2 ways. So the if part, you can also use this arrow. That is this, you are moving from left to right. So if rho xy is actually equal to 0, then you have to go back. Okay, when rho xy is equal to 0, what happens? It says if x equals y. So if this is equal to 0, we have x equals y. The same way, the other way, only if x equals y, then you have rho xy to be 0. So this is trivial. That is why it is called trivial metric. So the only if part says when x equals y, then rho xy is equal to 0. So that is what we have. Then we move to the third one, which says that the distance from x to y is actually from y to x. So the distance from x to y is actually equal to the distance from y to x. So now, if you check, right, if you check this, when x is not equal to y, when x is not equal to y, so let's check this first one. When x is not equal to y, you have rho xy to be 1. When x is not equal to y, you have rho xy equal to 1, which is same thing as what? Rho yx when y is not equal to x, right? So we have to consider 2 cases here. When x is not equal to y, we have rho xy to be 1. And when y is not equal to x, that is, you can interchange these, right? You can interchange them. Here, you have rho xy, then change it. Then you have yx. So when you have yx, you change anywhere you see x here also to y. So when y is not equal to x, you still have 1. The same way, when x equals y. This is why this is a trivial metric once again. Very simple. It's just trivial means obvious, like it's very obvious. You can just conclude from your given assumptions. So rho xy is equal to 0, which is also when we interchange y and x, the distance between y and x, when y is equal to x. So this is trivial. Alright, so for the fourth axiom, so we want to show that the distance from x to y is less or equal to distance from x to z plus distance from z to y for all z in x. So z is also in x. Remember from the first axiom we proved that this is less or equal to 1 for every z in x, so we can also have 0 less, or the distance from x to z is actually less or equal to 1. Remember also we can say 0 less or equal to by interchanging, right? So we said this is trivial, so this we can do. Obviously we want to check for this, right? This is what we want to check for. Now if you check this, let me rewrite it. So when rho xy is actually 0, remember it can be equal to 0, so this can be 0. This is equal to, remember xz can also be 0, this can be 0, so you have 0. This can also be, xy can be 1, so definitely this will be less than 1 plus 0. Also this can be 0 plus 1 is less than, then this can be 1 plus 1, right? This can be 1, which is 1 plus 1, so it satisfies this triangle inequality. So when you put in all these values, remember rho of xy can be 0. Remember the conditions, it can be 0 when x is actually equal to y. This can be 0 when x is equal to z. This can be 0 when z is equal to y. Remember those conditions before you apply these. But with everything, when you apply them, it will satisfy this triangle inequality. So yes, then we've proved this. Then we move to another example. I will try to solve probably one more example. So if you need any clarity on any example you find online or anywhere in class and you don't understand, put on the comment section, then I'll check them and solve and get back. Thank you.